Good morning, students. Welcome to another class. So we're discussing this chapter determinant, and we are talking about the inverse of any matrix with the help of the determinant, that is by the formula adjoint A by determinant of A. So today we will discuss the exercise of NCERT, exercise 4.5. So here's the first question. You need to find the inverse of the given matrix. So here is one matrix is given, 2, minus 2, 4, and 3. This 2 by 2 matrix is given. You need to find its inverse. So for that, what is the formula? Formula is adjoint A by determinant A. So for that, first of all, you need to check the determinant value, that is, it is singular or non-singular, that is, the determinant is 0 or non-zero. So let's check this determinant value. So determinant of A is given by 3 to the 6 minus 4 to the 4 into minus 2, then again minus 8. So 6 plus 8, 14. So A is non-singular. So we can easily find the inverse, that is adjoint A upon determinant A. Now I told you that adjoint A for 2 by 2 matrix. How to find this adjoint A for 2 by 2 matrix? Just exchange its diagonal elements, that is 3 here, 2 here, and just add minus with the off diagonals, that is, that will be plus 2 and that will be minus 4, right? So that's the adjoint of A, 3 2 minus 4 2. Now adjoint A upon determinant A. So put the value A inverse equals to 1 by 14, 3 2 minus 4 2, this 2 by 2 matrix. So this is your answer. You can just take this 1 by 14 inside of this matrix, or you can write down outside of it. So that will be the answer of this inverse of this matrix given by A. Okay, so moving to the next one. Question number 6. 2 by 2 matrix is again given, minus 1 5, minus 3 2. So first of all, check it is singular or non-singular. So determinant of A is given by minus 2 plus 15. So it will be 13. So A is definitely non-singular. So you can easily find the inverse. So firstly, find this adjoint, that is exchange the diagonals and add minus to off diagonals. Okay. So that will be 2 minus 5 plus 3 and minus 1. So that will be your adjoint, and just divide this adjoint with the by this determinant of A. So you will find A inverse. Same here, you can take this 1 upon 13 inside of this matrix, or you can write it outside as it is. Whatever is you are comfortable with, you can do that. So that will be your answer. So moving to the next question. Question number 7. 3 by 3 matrix is given. You need to find its inverse. Now look at here. This is lower triangular matrix is given. Since this after the diagonal, the lower portion, all the elements are there 0. So you know how to find the determinant value of this type of matrix is given. So the determinant value is given by 10, since 1 into 2 into 5. You know that just we need to multiply the diagonal elements if any triangular matrix is given. So finding its determinant value is just multiply its diagonal elements. Maybe it's upper triangular, maybe it's lower triangular. So just multiply it. So 5 to the 10. So definitely it will be a non-singular matrix. So now first find its adjoint. So adjoint means you need to write down its cofactors and then take its transpose. So adjoint A is given by 10 minus 10 2, 0 5 minus 4 0 0 2. So cofactor of 1 is 5 to the 10. So write it 10 here. Cofactor of this 0 is, just eliminate this 2. So 5 2 is 10 and 3 into 0, that will be 0. So minus 10. So minus 10 here. And now just for this 0, you can again write down for this element, just remove this 2. So 4 2 is 8. And then minus 3 2 is 6. That is 2. 2 is here. Okay. So like that, find the cofactors and then take it transpose, or you can write down the cofactor of this element here. Just take it after taking transpose, you can directly write down, or you can write down the cofactors and write down transpose here and then write down this adjoint. Okay, you can do it in rough and you can easily write down the answer, or you can solve it in a paper also. So adjoint A is given by 10 minus 10 2, 0 5 minus 4, 0 0 2. So this is a 3 by 3 matrix, and now A inverse is given by adjoint A upon this determinant A. That is, divide this matrix adjoint A by 10. So 1 upon 10 into this adjoint A. So this is your answer. Same here, you can take this 1 upon 10 inside of this matrix, or you can write it down outside of it. So that is your answer. So moving to the next question. Find the inverse. Another 3 by 3 matrix is given. You need to find its inverse. Now look at here. Firstly, find its singular or non-singular. Okay. So A is, just break this determinant. You can use row or column operation. Then you can easily find this determinant value, or you can just simply break this determinant. Just write down the values of it. So here I'm taking the first row for breaking it. So 2 into minus 1, and then minus 1 into, just remove this 2 line, there will be 4, and then 3 into 8 minus 7. So that will be, answer is minus 3. Definitely it is non-zero, so it will be non-singular matrix. Now then find its adjoint. Okay, so now for this finding this adjoint value, just take this element and firstly find its cofactor. So cofactor for 2, it will be minus 1. Here it is. Cofactor for 4, just remove this first column and the second row. So you will find 1 minus 3 2s are 6. So 1 minus 6 minus 5 into minus, that will be plus 5. Since in this place you need to add minus, since I hope you remember this minus 1 whole to the power I plus j, the cofactor form. I hope you remember. If you forgot, then check this cofactor previous videos for cofactors minus. Check this out. So next cofactor for minus 7. So minus 7. So remove the third row and the first column. So 1 0 0 and then 3 plus 3. So here it is. So like that, write down all the elements. So ultimately the adjoint is given by minus 1 5 3, minus 4 23 12, 1 minus 11 minus 6. So this is this 3 by 3 adjoint A, 3 by 3 matrix, which is adjoint A. Now A inverse is, just divide this by minus 3. So minus 1 upon 3 into this adjoint. This is your answer. Same again, that you can take this 1 upon 3 minus 1 upon 3 inside of this matrix, or you can write it outside. Whatever is suitable for you, you can do it. This is your answer. Okay. So moving to the next question. Find the inverse. So here 1 0 0, 0 cos x sin x, 0 sin x minus cos x. So first of all, find the determinant value, which is given by minus 1. So 1 into minus cos square x and then minus sin square x. So ultimately it will be minus 1. Definitely it will be, it is a non-singular matrix. Now find its cofactors and then its adjoint, that is this cofactors and its transpose. So adjoint A is given by -1, 0, 0, 0 minus cos x minus sin x, and then 0 minus sin x cos x. Okay, you can check here that if we consider this is a 2 by 2 matrix, now look at that, we are using the rule for 2 by 2 matrix for finding the adjoint, that is exchange the corners, that is the diagonals, minus cos x, and just add minus sign with the off diagonals. Look at here, minus sign with the off diagonals. Okay, and so that will be the adjoint. Now just take this, divide this adjoint with the help of -1. You can take this -1 inside of it, or you can leave it outside of it. Here I'm taking inside, so it will be 1, 0, 0, 0 cos x sin x, and 0 sin x minus cos x, same as A. Okay, so moving to the next question. These are very easy questions for finding inverse. Now after this inverse, you need to use this inverse for finding the solution for a system of linear equations. Some with 3 unknowns or 2 unknowns, system of equations are given, linear equations will be given. You need to find the value of this unknowns, that is x, y, z. You need to find the value, or you need to solve the system. So moving to the next question. Let A is a 2 by 2 matrix, 3, 7, 2, 5. B is 6, 8, 7, 9. Verify that AB inverse is given by B inverse into A inverse. So you know this is a property for inverse. We already discussed this property. Now here we need to prove this property with the help of an example. So first of all, AB inverse, and here B inverse, A inverse. 3 inverse you need to find, that is A inverse, B inverse, and AB inverse. So firstly find A into B. Here all the calculations are given. So multiply this matrices 3, 7, 2, 5 and 6, 8, 7, 9. So multiply it. I don't think that I need to explain it again and again, since you know how to multiply the matrices. So AB is given. Now you need to find its determinant value, that is AB. Just multiply them. 67 into 61 minus 47 into 87. So this is your homework. So multiply them and find, or check it that it will coming -2 or not. So since determinant of AB is -2, so it will be non-singular matrix. So you can easily find its determinant, inverse. So adjoint of AB, just exchange the diagonals, that is 61 here, 67 here, and just add minus to the off diagonals. So here it is, -87, -47, and then divide it by -2. Okay. So here I'm taking this -2 inside of this matrix. So it will be given by this. So this is AB inverse. Now we need to find A inverse and B inverse. So for that, you need to find, first of all, the determinant of A and the determinant of B. So A inverse is what? Look at that. A inverse. So first of all, find its determinant value. So determinant of A is given by 15 minus 7 is 40, that will be 1. Now adjoint of A. Adjoint of A is, just exchange the diagonals, that is there will be 5 and here it is 3 and there will be -7 and there will be -2, and divide this one by 1, that is the same as it is. So 5 -7 -2, 3. That will be A inverse. Now talking about B inverse, so firstly find the determinant value. I hope you remember the property that is determinant of A into B is given by determinant of A into determinant of B. So from here you can easily write down this what is the determinant of B, but still I'm just showing this. So there will be minus 2. So determinant of B is minus 2. You can use that property of determinant also, or you can easily find the determinant value by just breaking this determinant. So 54 minus 56, there will be minus 2. Now just exchange the diagonals and add minus with the off diagonals. So it will be 9, 6, minus 8, minus 7, and just divide this by minus 2. So here it is. Now just multiply them, B inverse with A inverse. So firstly write down B inverse and then A inverse. Okay. And then multiply. You know the rules for multiply. Just row with column. Multiply it. You will find this determinant. Now look at, this matrix. Now it's minus 61 upon 2, 87 by 2, 47 by 2, minus 67 by 2. Now what is this? This is AB inverse. So we proved it. Clear? So that's the way to verify this property of this inverse. AB inverse is given by B inverse into A inverse. So moving to the next one. If A is given this 2 by 2 matrix 3, 1, minus 1, 2, show that A square minus 5A plus 7I equals to 0, or this 0 or O means this is a null matrix. Hence, find A inverse. After that, you need to find A inverse. First of all, you need to show this equation. So first of all, find A square. So A is given 3, 1, minus 1, 2. So A square is just multiply them, and you know the rules of multiplication, that is row with column. So multiply it, you will find this 8, 5, minus 5, 3. I'm not explaining this one. Your work is to write down the steps, that is after multiplication, the values you need to write down. So moving to the next, this equation, A square minus 5A plus 7I. That is I is identity of 2 by 2. So write down the matrices, that is A square is 8, 5, minus 5, 3. Then 5 into A, that is 3, 1, minus 1, 2. And then 7 into identity, that is 1, 0, 0, 1. Just add them and you will find there will be a null matrix. Okay, so first we prove that this equation is true. A square minus 5A plus 7I is equals to null matrix. Now find the A inverse from this given equation. So A square minus 5A plus 7I is 0, or O, you can say null matrix. So from here you can easily write down the 7I is equals to 5A minus A square. Right? Now multiply it by A inverse from the right side. So A into A inverse and then A square, just break this A square, A into A inverse. So A into A inverse is identity. So just put identity here and here also. So 5I minus A. 7I into A inverse is equals to 5I minus A. So 7 A inverse is 1 upon 7 into 5I minus A. And now put the value of I and A. I is what? 1001. Multiply this by 5. That is 5005. And then minus of A. That is 3, 1, minus 1, 3. And then 1 upon 7 into this. Simplify this to 5 minus 3 is 2. And then 0 minus 1 minus 1. Then 0 minus minus plus 1. And then 5. Then 5 plus 5 minus 2 is 3. So 2 minus 1, 1, 3. and divide this matrix by 1 by 7 is your A inverse. You can verify also by finding A inverse from A. You can find A inverse from this matrix A also, and you can verify this, that both the inverse are same or not. You can verify it. So verify it by yourself. So here is your A inverse is given by 1 upon 7, 2 minus 1, 1, 3. So this is your answer. So next question, from this matrix, find the numbers A and B such that A square plus AI plus B, A square plus A into capital A, that is matrix A, plus BI is equals to null matrix. So first of all, same process, firstly find A square. A is given 3, 2, 1, 1. So just multiply it by again A, you will find 1, 11, 8, 4, 3. Again, this is your work to write down the calculation, write down the steps in between these two matrices. So write down the steps after multiplying and adding. Write down the calculation. So now just put the values of A square, A and I in the left hand side. So it will be A square plus A into matrix A plus BI. So put A square and I. Okay, so 11, 8, 4, 3 plus A into 3, 2, 1, 1 and then B into 1, 0, 0, 1 is equals to null matrix is given. So now just add this 3, but you will find 11 plus 3A plus B. And the second element is 8 plus 2A, and then 4 plus A, and then 3 plus A plus B is equals to null. So from this equation, 4 plus A, you can easily find the value of A. Clear? And from any other equation, from this equation also, you can find A. Whatever equation you want to choose it and find the value of A and B. So here I am choosing this 4 plus A is equals to 0. That means A is equals to minus 4. And you can easily put the value, one of this two equations, that is 11 plus 3A plus B is 0 or 3 plus A plus B is 0. From any of them, you can easily find the value. Here I am choosing 3 plus A plus B is 0. So put the value of A, that is minus 4, and plus 3, that will be minus 1. So B will be 1. Okay, you can choose another equations also. Since 4 equations are there, you can choose whatever you want to choose it and solve it. You can find this value of A and B. Okay, so A is minus 4 and B is 1. So if any problem or any doubt is there, you're free to ask. And in the next class, we will talk about the simultaneous linear equation and how to solve the simultaneous linear equation with the help of inverse. Okay, so till then, practice it. Thank you.